Hello and welcome to my class. I'm Grolin Annalisi from ThinkMo Education. I'm currently a Cisco technology lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +6 5834444290. Today's topic is dynamic routing, EIGRP theory and experiments. Before the official start of class, let me start with the unfinished part of the last lesson about static routing. Tell everyone. Then talk about the dynamic routing part and the first dynamic routing protocol. It is also a routing protocol proprietary to Cisco, EIGRP. Do you guys remember this topology? We've covered this in the last class. And the interconnection of 3 devices is also finished. Here we have not configured. This corresponds to the last part of the static route. That is load sharing. Let's first look at this picture. There are now 2 devices. There is a network segment behind the RB. 8.8.8.8. Everyone can see. Here in RA there are 2 lines. Can reach this network segment. Look in the routing table. Has 2 next hops. One is the address of this interface. One is the address of the interface below RB. That is, we have 2 next hop addresses. Go up and go down. Can reach the same destination network segment. We talked about the principle of adding tables to routing. If it is the same routing protocol, we will compare the value of cost. But static routing is different. If the management distance is the same. Same goes for routing metrics. Then both routes will be placed in the routing table. This is what it looks like in the picture now. Load sharing. When data is forwarded, 2 routes can take effect at the same time. Let's finish this experiment now. Because there are some leftovers from the last class that I didn't do. Let's turn the device on first. During the opening, let's look at this picture. I added 2 switches in the picture. When everyone is doing experiments after class, also try. Let you touch the device first. That is, when you add nodes, just add a second layer here. When selecting an icon here, choose this. It doesn't need any configuration. Just put it here. I have entered the planned network segment on the map. Let's take a look at the situation today. It starts up a little bit slowly. Let's review first. If I want to configure it, we first under these 2 interfaces, configure the address. Then on the router on the right, configure a loopback port address. 8.8.8.8. A host route with a 32-bit mask. OK. Now in. We start configuring. Open them first. On the left is R7. I give it a name. It is slightly slower. If the device is turned on after, everyone must remember. You need to name the device first. Because for many simulators, inside is the same. When you have too many devices, its name will be cumbersome. So I just type them in as R1 and R2. OK. After we rename these 2 devices, we'll enter the interface. It is configured with an address. I put a screenshot of this image above. Let's do an experiment. In this process, just look at my configuration. This is basically the same as the previous static routing. So there is no need for everyone to practice after class. Enter the 00 interface. The address we assign to it is 10.1.1.1. Then enter the 01 interface. That is the following network segment. 20.1.1.1. Then the R2 device. (20.1.1.2). Finally here. Give it up the address of a loopback port. The address of the loopback port is 8.8.8.8. Here to remind everyone. If you up a loopback port, you do not need to manually shut down this interface. It is enabled by default. We can check. Show IP interface brief. Let's check the status of the interface. You can see. The loopback interface is now enabled by default. It does not need manual shutdown. A classmate once asked me a question. When typing the command, what does this BR mean? You can view some brief information about the interface. For example, if you only check the IP interface here, it will be more informative. So if you want to just see a summary, or say you want to just look at some output, you want to add this BR to the current list, called brief. Here are some configurations for the base of the two devices. After the interface is configured, we're going to test the direct connection first. This is the eternal truth. Test 10.1.1.2. That is, test the peers to see if they can communicate. Same. I will test 20.1.1.2 again. Make sure that the directly connected interfaces on the two links are not misconfigured. I hope now. From the router on the left to 8.8.8.8. So how many routes do I need to enter here? If I want to implement a load sharing, how many routes do I need to enter? Okay. I need to enter 2. We first need to enter configuration mode. Remember how to configure static routing? IP route 8.8.8.8. We go to a loopback address like this. This is an exact host route. The next hop is 10.1.1.2. Then go up now. Similarly, I will enter another next hop. 20.1.1.2. I configure them. After configuration, we can view it on the device. Show IP route. Look at the routing table. This achieves the same effect as before. For static routing, if now going to the same destination, the next hop is now specified. And do not specify other parameters. It is load sharing by default. We can test it now. For example, I am here to ping 8.8.8.8. Okay. It is able to communicate. Then we use tracer out. Give it a track. Let me tell you first. If you want tracer out to be faster, you need to turn off the function of domain name resolution here. You can remember this command. No IP domain. We enter configuration mode. You must turn off the function of domain name resolution. Otherwise it will be slightly slower. After closing, we start traceroute. I now wish to trace 8.8.8.8. Then go to check. Which nodes will it pass through? I'm now back to my daily order. For example, I'm going to traceroute it now. If using traceroute,